Today, we want to look at correlation and regression. Your answers to me will help me give you more. Okay. What is correlation? Who can give me a synonym for correlation? Who can give me a synonym for? Yeah, Tina.
Relationship or
you.
connection.
Thank you. Who else can give me another name?
Comparison.
Seidu. Your hand is up. You can lower it if you're done. Nexus and several.
Okay.
Now, correlations are viewed as strong or weak. For example, the relationship between a brother and a sister is strong, but that of cousins can be weak. A correlation can also be positive or negative. For example, what do you think is the relationship between consumption and income? Is it positive or negative? If you say whatever, I will ask you why. So think of the why before you say it. Is it positive or negative? Remember, I told you that it is your energy that will give me the energy. Yes, Tina.
There's a positive relationship. The higher your income, the higher your expenditure.
Super. What about price and quantity demanded?
They are inversely related.
Very good. Now, the strength of the correlation is important. You see, when I write a number, whether it's negative or positive is irrelevant. What is relevant is the value, the absolute value that will determine the exact strength of the relationship. Now, on your screen, the relationship here, is it positive or negative?
Positive.
It's positive. What about this second one? Is it positive or negative?
Negative.
Okay, there is a statistic you can use to measure correlation. It's called Pearson's product moment correlation coefficient. You have to calculate it. We shall calculate it easily using Excel today. The value will tell you whether the relationship is strong or weak. Now, let me ask you this. If I write something like this, negative 0.87, and I write 0.72, which of these show a strong relationship? The top one or the down one? Which one?
The top one.
Top one.
Exactly, it's a top one because the strength of the relationship is determined by the absolute value. So correlations are very important. The more you understand how correlation works, the more you can. Remember, correlation is just a method. It's an approach. An approach you can use to establish relationship. Now, it's not the only approach. There's another approach, which is not correlation. Now look on the screen and tell me these figures. What kind of correlation is it showing? Let's start with the first one here. Is it positive or negative or what? Tina.
Positive.
Positive. The first one is positive.
The next one?
Negative.
The next one? I know the speed at which you start to go down.
The next one is positive. It's positive.
It's negative.
But if it goes here, this is positive.
Please, the one's talking behind the scene. I think it'll be better for you not to talk or to rather raise your hand and talk. Okay, it helps me. The very person behind the scene, don't chop. When you raise your hand, then you can now talk well. Yes, Vera.
It's Tina speaking, sir. I'm with her.
Okay.
Okay, so the next one is positive.
This relationship is said to be quadratic. Take note. You see it somewhere. It's quadratic. is nonlinear. Okay, it is positive at some portion, and then it is constant at another portion, and then it's negative at another portion. The last one is logistic relationship. So you got to know the relationship. There can be different things, and each relationship matter as to what you want to use it for. Correlation is just a relationship. It's just a relationship. What is interesting is that correlation is about association, but regression is about causality. What is regression? Regression looks at the causal relationship between variables. It's also a statistical technique. It's a method. It's an approach. So you want to look at a relationship between variable. The variable can be a dependent variable. Please write as much as you can today, because the information I'm doing, if you are writing, that's the only way you can understand. If you're not writing, it's going to be tough to understand. Look at this relationship here. It's called a simple regression. The elements of a regression are just 4. Take note. The first element of a regression is usually on the left-hand side of the equation. It is called the dependent variable. There are several names for that. It is sometimes called a regressand. Regressand. It is sometimes called the outcome variable or a response variable. And it's sometimes even called the explained variable. Explained. It is a simple regression. Why? Why do you think it's a simple regression? It's because on the right side, there is another variable, which is called an independent variable. You can give me another name for the independent variable. If the dependent variable is a regressand, the independent variable is what? Regressor. Regressor. Okay, regressor. Now, if the dependent variable is the outcome or response, the independent variable is a predictor. So it's also another way of calling the independent variable, predictor. If the dependent variable is explained, the independent variable is explanatory. Explanatory. Now, because the independent variable here is just 1, this is a simple regression. If it's more than 1, it's multiple regression. Now, this independent variable is the one that is influencing the behavior of the dependent variable. So X is behaving in a certain way, and each time X behaves, Y behaves in a different way or in a certain way. So X is causing the behavior of Y. But by how much? By how much does X affect Y? That is determined by the beta parameter. The beta parameter tells you by how much the independent variable affects the dependent variable. It is said to be the marginal effect. A change in the independent variable will likely cause a change in the dependent variable. How much that change will be is dependent on the value of the beta. Therefore, the beta parameter tells you how much the independent variable affects the dependent variable. There is a constant or the intercept that has no economic interpretation per se. It's just for aesthetic beautification. You should find a more meaning about the alpha or the intercept. That leaves us with one final variable, and this is known as the error term. The error term is the unexplained part of the regression. It has several names. Who remembers some of the names of the error term? Have you ever heard about any name apart from the error term? One, you can have the residuals. Take note of all this. If you check some of our questions, I always ask them. Okay, the residuals. You have things like the disturbance term, the stochastic noise, the random noise, the white noise. You have this, schematic error. You have the unobserved heterogeneity, the disturbance term. All of these are names, idiosyncratic error. They are names that we use to refer to the error term. In other words, this error term deals with other factors that can affect the dependent variable, but they've not been captured in the model. The essence of regression is to establish the relationship between the independent variables and the dependent variables and use that for prediction. Use that for prediction. In order to do that, in order to establish the clear relationship between the dependent and the independent variable, the errors must be reduced because these errors interfere with the relationship. It got to be reduced to a value of 0. And so there is an assumption in regression which says that the expected value of the error should be 0. What it means is that we expect that the average, by the way, the expected value of any number is the average of the number. The expected value of the error or the mean of the error should be 0. It's just an assumption. So this is a simple regression. But in a multiple regression, it's not the same as that. In a multiple regression, what do you see? Who can tell me? What is a clear difference, obvious difference between a simple and multiple regression? Yeah. As you see it. What is the difference?
All right. Notice that it has a multiple independent variable.
Okay.
The multiple
Give me some of
model.
the independent variables.
So that is the A1, B1, BI, sorry, AI, BI, CI, DI,
Lovely.
EI.
That's it. That's it. So that is what the multiple regression does. So you have multiple independent variables. Some of the independent variables can be numerical. Some of them can be categorical or dummy. Take note, because this is a question somewhere. Okay? And you got to know the distinguishing difference between the two of them. Next, we are going to look at the difference between a regression model and a regression equation. One, a regression model is specified. A regression equation is written. But there are two main differences between a regression model and then a regression equation. We'll look at that after this very slide. Look on your screen. What you see here is a regression model specified. It says that the wage of a person is affected by the education of the person. It is also affected by the experience. It is also affected by the position, and it's affected by the ability. Yes, Tina.
Doc, you said a regression model is
Someone's
specified.
microphone is on. The person should mute himself.
Doc,
Yeah.
please, you said a regression model is specified, and the equation is what?
It's written.
Okay, thank you so much.
So the wage is affected by all these factors. The UI is the error term, which indicates other factors that can affect wage, but have not been captured. What do you think are the relevant other factors that can affect wage but have not been captured? Don't worry, I'll be the one to determine what is relevant. So you can give me other factors which are inside the error but have not been captured here. What other factors? Wage. One factor can be overtime. Overtime has not been captured here. The type of work, which is the risks associated with the work. There's nothing on productivity, nothing on macroeconomic factor, okay, nothing on minimum wage, and all of these do not affect the wage because they are general. Okay, they are general. Now, we are more interested in things that are particular to a person. Other factors that can affect the wage, we've indicated a type of work, the type of a job. Also the location. Okay? If the work is located, if you are located in London, the way you'll be rewarded is different from if you are located outside of London. Experience is already captured here, so there's no need to consider that. All of these are called unobserved heterogeneity. Take note. Unobserved heterogeneity. Let's go to the next one. The blood pressure of a person is affected by the age of the person. It's also affected by the weight of the person, which I know most of you will agree. The stress level of the person, the pulse of the person. But you will agree that there are other factors that can affect the blood pressure of a person. All of them cannot be captured here, but they are inside the error term. Who can show me, who can indicate other factors that can affect or is connected with the blood pressure, which have not been captured here? Nobody should mention broken heart. Yeah.
Hereditary.
Hereditary. Very good. What else?
So the food you eat, if you eat a lot of junk food.
It's a lifestyle.
No, no. Lifestyle is too broad, so you can't actually say lifestyle. So
No,
food
the
we
food
eat.
you
Let's take diet. Yeah.
Diet.
Diet is key. What else? So you have genetics, you have diet, you have exercise, all of these, and you even have other diseases. Sometimes other diseases you have can also affect. Now, we are not interested in whether it will affect smoking or whether it will affect negatively or positively. And by the way, alcohol, smoking, all of them enter into your body like food. So they all go into the diet. Yes, right.
Doc, pregnancy can trigger.
Excellent point, because I was really looking for that. Okay. Pregnancy can affect the blood pressure. So I could give you a situation where I give you a model, and then I will tell you to mention 5 unobserved factors that can affect the dependent variable. You should be able to know. When you pick any phenomenon in the world, you should be able to do it. Let's look at another specified model. This is known as the quantity demanded of a commodity. The quantity demanded of a commodity is affected by the price of the commodity, the income of the people, the advertisement, and whether the good is a complement or substitute. Enoch, you have a question?
Yes, Doc. The B0. Can you kindly explain what that is?
It's called the error, the intercept. It's also known as the constant. It tells you that if there is no factor affecting the dependent variable, there could be a relationship. There could be something that will have a relationship with the dependent variable. But whenever there are other independent variables, that value is useless. In other words, it doesn't have any economic meaning except for beautification. The best way to understand this is that it is useful for prediction. If you want to predict, suppose you know the price of a commodity, the income, the advert, and the complement price. If you know all of these, you can predict what a quantity demanded will be. And that beta zero will play a major role at that point in time. That's it.
Thank you, Doc. Thank you.
Now, what other factors can affect the quantity demanded that have not been captured here? Apart from this, like I said, nobody should mention taste and preferences. But of course, there are other factors that can affect the quantity demanded of the commodity, but are not captured here. One, population. Population. If the population goes up, quantity demanded will go up. Two, expected price. If you expect that prices are going to go up, you buy more now. Three, weather or seasonality. During a particular season, it can cause the demand or the quantity demanded of a commodity to go up. What else? There.
Technology, the technology used can
Okay.
also affect.
Yeah, the challenge with technology is that it's difficult to quantify.
Okay.
Yeah, but government taxes and subsidies, government regulations, taxes and subsidies, they also play a very significant role in affecting the quantity demanded.
Speculation of prices, price changes,
The
and
same,
sorry,
the same thing as price and price expectation.
and price of other related commodities.
We've already mentioned substitutes and complements. Okay? And that is the same as a price of other related commodities. Okay, now I want you to look at this final bullet. Look at it carefully. The final bullet is the same as the first bullet, but there are two main differences. The first one is called a specified regression model. The last one is known as an estimated regression equation. What's the difference? Two. What's the difference? You check carefully and you will notice that the first one has an error term, the last one has no error term. So the estimated equation has no error term. The specified model has an error term. The estimated equation has numerical coefficient, but the specified model has beta parameters. Know the difference. I ask this all the time. Okay. So this is what we mean by the specified model and then an estimated equation. Let's go to the assumptions of regression. You will be doing a regression. You will be running models of regression in both Excel and R. That of the Excel we shall do it today. If you want to follow with your own Excel sheet, it will help you. What are assumptions? Assumptions are certain things that have got to be in place for certain things to work. Let me repeat. Assumptions are certain things that must be in place for certain things to work. For regression to work, certain assumptions must be there. The first one is linearity, which means that the connection, the relationship between the dependent and the independent variable must be linear. The relationship must be linear. Now watch this. This horizontal line is a linear relationship. This vertical line is also a linear relationship. This one going downward is a linear. This one going upward is also linear. The relationship between x and y must be linear. But this one is not linear. It's curvilinear. That is not linear, it's quadratic. So understand linearity. Oh, you have to understand all the assumptions of regression. It's called a classical linear regression model. The Gauss-Markov assumption. Welcome to the world of the masters. The second assumption is called normality, but it has to do with the normality of the errors. Please note this, that the errors can be represented by UI, by EI, or by epsilon I. All of them, the same thing, error. One of the assumptions of regression is that the error, the expected value of the error must be 0. I said it multiple times. What does that mean? What does that mean? What that means is that because remember that your goal in a regression is to minimize the errors. We call it minimizing the error sum of squares. That's your goal. The goal is to cut down because you want to establish the relationship. You want to clearly estimate the relationship between the independent variables and the dependent variable. For example, you want to look at the factors that are affecting the fighting in the class. It might be that somebody was eating and somebody told him or her to stop. And that generated into fight. And that was also escalated by somebody slapping another. And that led to pandemonium in the class. In the process of trying to establish this relationship, there are other things you don't even know. You don't even know. But those very hidden, latent factors, they were the one causing the problem. But you can't actually put a finger on them. The assumption of regression is saying that the average of those things should be 0. In other words, make sure they are not there. Make sure the errors are not there. Ensure that the exact relationship between the dependent and independent variable, that is the only relationship driving the relationship. Normality, normally distribution, okay? Normally distributed variable means that it has a 0 mean. The distribution has a 0. Another assumption of regression, and you got to know it as well. See, anytime, for example, if I give you some numbers like 2, suppose I give you numbers like 2, 3, and then 5. Ladies and gentlemen, 2, 3, 5, what's the average? You can find the average, and the average represents the center. The center. But then, if you calculate the average, you can also find the deviation from the average. You can take each one and see how far it is removed from the average. This deviation is called the variance. And the square root of this variance is what we call the standard deviation. Now, one of the assumptions of regression is that the errors, remember, the errors are normally distributed is the same as they must have a 0 mean. It's also the same as the fact that saying that the errors are stochastic. It's the same thing. Now, anytime you calculate the center of something, you got to calculate the deviation from the center. So once we've talked about a mean, you've got to talk about the variance or the deviation or the spread or the dispersion. And one of the assumptions of regression is that the dispersion, the deviation, the variances should be homogeneous. In other words, there must be the assumption of homoscedasticity. The errors must be, the variances of the errors must be constant. It must not be heteroscedastic. I told you, write everything. You don't have to understand everything, but write everything. Okay. Find the difference between homoscedasticity and heteroscedasticity. It has to do with the variances of the errors. It's all about the errors, to be honest with you. It's all about the errors. The next assumption is also about the errors. There must be no autocorrelation. You are trying to find out what caused the fight in the class. That's what you're trying to do. In the process of finding that, you made a mistake with one guy. You accuse one guy when you shouldn't have accused the guy. And then you also accuse another guy when you shouldn't have accused the other guy. They are double mistakes. These errors must not be correlated with each other. So there should be no serial correlation, no autocorrelation. It's the same thing. What does that mean? It means that the errors in one observation should be independent or orthogonal with the other one. I don't depend on you means independent. It also means orthogonal. When you go home, try and use some of these words in your homes. It will help you to be able to understand what you're doing. The moment you get home, you talk to your spouse and say, I hope that you and I are not orthogonal. You know what that means? When you say you and I are not orthogonal, you're saying that you and I are not independent. We depend on each other. That's what you're saying. It's about the errors. But that is not the same as multicollinearity. Multicollinearity is not about the errors. It's about the independent variables themselves. Now, suppose you are telling me that the wage, the salary that you are earning is affected by the education as well as the experience. Suppose in your company, you were told that anybody who spends 5 years in the company is sent to do his MBA. The person then returns back to school, he returns to the school, to the company, and will be given a double salary after finishing the MBA. So you are now 3 years in the company. So you know you have how many years left? Because it's 5 years, 5 years. So you know that you have 2 years left. So what you decide to do is to play your cards well, and truly you stayed faithfully to the company. And when it is 5 years, you were actually sent to do your MBA. You came back and boom, your salary was increased. Question: what led to the increase in your salary? Was it the MBA you had, or it was experience you had? Was it a 5 years experience you had, or it was the 2-year MBA? Which one led to the increase in your salary? Who can tell me? Which one? Is it experience or the education? Well, you can't tell because the two are highly multicollinear. It means the two are correlated highly. You see, multicollinearity exists when two independent variables are so highly correlated that it becomes difficult to disentangle the partial effect of one from the other on the dependent variable. It becomes difficult to separate their effect, individual effect on the dependent variable. Why? Because they are so correlated. You see, your 5 years education, your 2 years education is as a result of your 5 years experience. And that is also why you got your increase in salary. Without your experience, 5 years experience in the school, there is no way the school is going to what? Send you to go and do your MBA, then return and come and bluff on someone. No way. That's multicollinearity. Now, the assumption of multicollinearity says that the relationship between the dependent between two independent variables must not be related. They must not be related. They might be unrelated. There should be no multiple. Try and understand the difference between multicollinearity and heteroscedasticity. It's a very, very important distinction. Now, before we try and practicalize regression, okay, let's look at dummy variable. I told you that sometimes some of the independent variables can be numbers. So you can have wage being affected by, say, education. Education is in numbers, right? 2 years education, 3 years education, and all that. However, you can have a situation where the wage is also affected by the location. The location. So if you are living in London, the chances are that your salary will be increased a bit because the cost of living in London is very high. But if you live in outside London, because the cost of living is a bit lower, that will change. So we can have a location being something like, inside and outside. So each individual person who will create that inside, outside, inside, outside. Now, these two are called levels. And the top one, the location, is known as a dummy variable. You see, the word dummy is like static, not changing, not moving. So you have a dummy, and each time you have a dummy, you have a dummy, you can choose to have levels. And the number of levels are always one more than the number of dummies. Please write it down. The number of levels are always one more than the number of dummies, which means that the number of dummies are always one less than the number of levels. The number of levels are one more, which means that the number of dummies are one less. Take note of this, very important. So when you have a dummy like, say, gender, how many levels does it have? Generally, how many levels does it have? Gender. Generally, 2 levels? Yes. Male and female. Okay. Generally. Generally. Of course, depending on where you are, there can be multiple. But that's why I use the word general. Okay. If the number, let me ask you, if the number of dummies are 6, how many levels would there be? If the number of dummies are 6, how many levels do you think there will be?
7.
7, exactly. 7. So understand dummy variables. All right. The way you interpret a dummy is not the same as the way you interpret a numerical variable. Interpretation of a dummy is unique. So here you have an example of a return on asset being affected by profit, the type of a company, and asset. The profits and the asset are numerical, but the type of a company is a dummy. It can be represented as domestic, being 1, or foreign, being 0. At this stage, anytime you see 1, it means that the firm is domestic. And watch it, anytime you see 1, it means that The firm type is domestic. So if you come and replace 1 under type, the 1 will be multiplying the 30, and so you will have 30 more. But if the firm is foreign, it is coded as 0. And when you put the 0 under type, 30 times 0 will be 0. So that will be 30 less. How do you interpret a numerical variable? And how does that differ from the interpretation of a categorical or a dummy variable? Well, the thing is about dummy variable is that within a year, they are not changing a much. So you cannot say that they rise and fall because they are not changing much. Okay, all right. So that's it. We'll come to more interpretation of the dummy when we have calculated all our analysis. So now, ladies and gentlemen, we are ready to look at a practical data set. And I've given them to you, Excel sheets. Okay. You can open the data set right now and let me know. Please, let me give you some 3 minutes and open the data set and let me know. So this is the Burkutu data set. Please lower your hands now. The Burkutu data set. If you go to the story, look at the story now. Burkutu is a local gin distillery. It's concerned about the demand for its favorite gin bitters. It's concerned. Why? Because quite recently, it's been hard hit by competition. New entrants into the market are changing things. So management are very worried. And management have asked you to determine those predictors, those independent variables that explain the quantity demanded of aquatic. Management is aware that price is one of the main determinants of aquatic. But out of the determinants, there are other ones that were defined as well. One of them was the price of complement, and then the average income of the customers. Remember that the price of complement is C, and the average income of customers is N. Please remember also that these are all in the data set. This is examinable. It's a pure exam question. Now, let's go to the Excel to look at the C and then the M. So you see that price is here, C is there, and then M, which is average income of the people, is there. What do you notice about these variables? They are numerical. They are numerical. They are not 0, 1, 0, 1, 0, 1. If they are 0, 1, we call them what? Dummy. Dummy. Now let's continue the reading. Apart from these, there are also other variables, such as location. So you see, we're told that one of the variables is location of the shop, the gin bitter shop, the location. And we are told that location is LU equal to 1 if the location is urban or 0 otherwise. It's 1 or 0 otherwise. So the word 1 means that it's a dummy variable. 1 means that it is urban. 0 means it's rural. So when you come to the Excel, there is LU given. And the LU is 1 for the first two. Why? Because when you go to the data and you look at the actual values, you see that the first one is urban. That's why it's 1. The second one is urban. That's why it's 2. But the third one is urban. Sorry, the first one is urban. That's why it's 1. The second one is also urban. That's why it's 1. But the third one is rural. Because it's rural, that is why it's 0. The fourth one is urban. So we expect it to be what value? 1. When you go to this one, you see that the fourth one is 1 as well. So we have coded the dummy variables. So dummy variable is LU. Please note that the column is LU. In other words, the column is urban. Anything that is not urban is 0. Anything that is urban is 1. The other thing that was mentioned here is occupation. The occupation of the people. And there are 3 kinds of occupation: teaching, fishing, trading. One of them is always the reference category. Take note. One of them is always the reference category. You see, the problem with watching things on Zoom is that you don't take notes if you don't take it. You are watching and watching and watching, and sometimes you are hoping and you know you're going to get a recording, so it doesn't even motivate you to do anything. It's a very bad way of learning. Teaching, fishing, trading, these are the occupation. But when you look at the story, only 2 of them have been given. How do we know? OT was 1 if the occupation is teaching, or 0 otherwise. OTR is 1 if the occupation is trading, or 0 otherwise. So of all these 3 kinds of occupation, which one was omitted? Which one was the reference category? Which one was given a value of 0? Who can tell me? Which one?
Fishing.
Fishing. That's it. So if I go to the Excel, and occupation teaching, anything that is not teaching must be given a value of what? 0. And occupation trading, anything that is not trading must be given a value of 0. Under religion, the last 3, by the way, I'm just jumping, are religion. And there are 3 kinds of religion: Christian, Muslim, Buddhist. And you can see that RC means Christian. So anything that is not Christian is given a value of 0. RM means Muslim. Anything that is not Muslim is given a value of 0. The fact that you have 0, 1, 0, 1 means it's a dummy variable. The reference category is always the one that is not mentioned, the one that is not given a value of 1. So go to religion. Religion, RC was Christian. Religion, RM was Muslim. But there was nothing of religion for Buddhist. That is why we know that Buddhist is a reference category. Sometimes you are asked to identify which is a reference category. And these are the ways to use to identify. Now, the first thing we are going to do is we're going to do 3 things in Excel. And you want to do this along with me. 3 things in Excel. See, if you are doing this, you're going to generate some good marks for yourself. Because what you are going to do is that you are going to take a picture of what you are doing. By the time we complete, just take a picture with it. And then you post that picture with your name in the Excel. So let's say that your name is KOA. You're going to type this name, KOA, in the Excel, and then take a picture of your screen and send it to me in the page. That is if you are doing it. That, you're not supposed to do it, okay? But I want you to do that and send it to me. Just add your name and ID as well. By the time we finish. So let's start. Look at your Excel sheet. There are 2 sheets at the bottom. I'm talking about the Brukutu Excel, not the Brukutu R. We are going to generate a descriptive statistics. I'm going to go so fast. And so you want to pay attention so fast. So the first thing to do is to click on Data tab at the top. Click on Data tab, and on the far right, you should see Data Analysis, and click on it. Now, if you click on Data tab, and on the far right, you don't see Data Analysis, let me know. Please let me know quickly. If you click on the Data tab, and on the far right, you don't see Data Analysis, let me know quickly, please. Nobody?
I don't see it, please.
I can see it, sir.
I also don't see it.
Follow me. Open your eyes, remove all, distraction around you and follow me strictly. It has to be strictly following me. On the top left, click on File. On the top left, click on File. You will see Options at the bottom. Options at the bottom. Click on Options. A pop-up will show. This is called Excel Option Parameter Dialog Box. Then in that list, click on Add-ins. 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 On the right, you will see Analysis Toolpack in the list. You will see Analysis Toolpack in the list. Okay. Click on the Analysis Toolpack. Please be careful. Be careful. I did not say Analysis Toolpack VBA. No, I said Analysis Toolpack. Click on that. Come down to the bottom. Under Manage, you will see Go. Click Go. You see Go. Click Go. A pop-up will show. In that pop-up, tick the Analysis Toolpack. There are so many things you can tick, but just tick the Analysis Toolpack and click OK. And when you do that, this time, you will see the data analysis on the far right when you click on the Data tab. Those of you who did that, can you confirm?
Done, please.
Perfect. Let's move on. Now click on
get add-ins.
So we are missing.
Don't worry, you can do it again later. Okay. I told you, follow me and follow me rigidly. Now, follow me and follow me rigidly. Click on Data Analysis now on the top right. Click on Data Analysis. Click on Data Analysis. Follow me. It is at this stage that when you click on Data Analysis, you tell me that you have just clicked, but I didn't see. Not when I have finished, then you say, should I go back to Excel options? Follow me, I keep saying. Because normally, when you are doing the thing strictly with me, you will tell me immediately. But if you don't tell me immediately and I finish, it means I didn't do the thing. Click on Descriptive Statistics. And I'm showing you what I'm saying you should click. Click on Descriptive Statistics and click on OK. OK. Now you see that you have the input range. And there's a white space to the right of the input range. Click the white space. That is where you are going to put your input data. Now, click on the top first letter Q in the data set. Click and drag. Click, hold, and drag all the way to the RM and drag all the way down. Click and hold. Oh. If you release it, you have to start all over again. If you remove your hands, you have to start all over. When you do that correctly, you will see that the cell A1 all the way to A1 all the way to I41 will be collected inside the input range. Okay. It will be collected inside the input range. Now click on labels in the first row. Okay. You have labels in the first row. Okay. Click on that. I just did mine. Then choose output range, which is directly under output options. Choose output range. Choose output range. And then you see a white space to the right of the output range. Click inside. And then select any empty cell on the right from column J. Select any empty cell on the right from column J. I'm just clicking the first cell. The moment you do that, I chose J1. The J1 will be collected inside the output range. Then come down a bit and select summary statistics, summary statistics, summary statistics, summary statistics. You are done. If you follow this rigidly, you click OK, it is going to generate the descriptive statistics for you. That's what it did. You have all these descriptive statistics. What you can do is to analyze it very well and just rearrange. Each one of them has the mean, the standard error, the median, the mode, the standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, count. So one thing you can do to arrange them is that you can move all of this. You can cut and you can paste them so that each one will have the number following it. And then delete the repetition. Again, if you can do this, you can do. If you can't do this, there's nothing you can do. You delete the repetitions. Delete the repetitions. So I'm going to do this. Okay. You're deleting the repetitions. If it's not a repetition, you don't delete it. I'm just deleting the repetitions. Then that's it. Now you can right click and choose delete. And all the repetitions will be gone. And a nice descriptive statistics for each variable is shown here. That's what you have. So you are able to get a mean and all of this. So what does this mean? It means that the quantity demanded of gene bitters, the average quantity, the mean quantity was 175. That is what it means. The mean quantity was 175. The average price was 15.1. And the average complement price was 125. So you can find the mean. If you want to know the standard deviation for the quantity demanded is 29.79. And you can have that. This is the first step. Generating the descriptive statistics. The descriptive statistics just gives you a preliminary analysis of everything you need. Second is to generate the correlation matrix. You remember that we've done correlation. So we're going to generate the correlation matrix. By the way, I hope somebody was able to do what I just did. I just hope. Somebody did? Right.
Yes,
Got
sir.
lost. Got lost on the way.
We are
Got
not
lost.
expecting everybody to do it. Just keep on. You are not there yet. You are not there yet. Keep moving. Keep on keeping on. 2 more to go.
Yes,
We're
sir.
going to generate a correlation matrix, which is also a table. To do that, click on the data analysis on the top right again. Choose correlation instead of descriptive statistics. Choose correlation. Double click it, and then the data, the correlation dialog box will open. The first thing you see is the input range. Click inside the white space to the right of the input range. And go and select all of the data, just like you did before. Click on the kill, drag it all the way to the RM, hold and drag it all the way down to the end. Once you are done, you see that the A1 all the way to I41 is collected. See, if you make any mistake, delete everything in the box and do it all again. Choose labels in the first row. Choose output range and click on the white space to the right of the output range. Just select any empty cell below this data and put your results there. I'm just going to select this one. Once you're done, click OK. Beautiful correlation matrix is going to be generated. And that's what it's just done. The correlation matrix is highlighted. Don't remove the highlight. It has a lot of decimals. Don't touch it. Go to the Home tab. Click on the Home. And when it comes directly below the Power Pivot or Help or anything, you will see General. You will see General. We just want to change this thing to 2 decimals. So click on the little arrow to the right of the General and select Number. The moment you click Number, everything will be converted to 2 decimals. This is our correlation matrix. You've got to pat yourself in the back for doing this. We're going to ask some questions. But under exam conditions, there will be 5 questions on this correlation matrix. Let's try to look at this in our own. So I'm going to just show you the replicated correlation matrix. This is it. That's what you see. This is the correlation matrix. Question number 1. Let's try to joke with this, play a little bit. What do you think is a correlation between price and price? Who can tell us? Price and price. P and P.
Perfectly.
It's 1.
1.0.
It's 1. What is the correlation between M and OT? M and OT.
M and OT.
M and OT.
No correlation.
Sorry?
No correlation.
There is a correlation. You're looking at it from only one angle.
Negative
0.003.
That is it. Remember, guys, if you look at the thing from this angle, you will see that nothing. But remember, that's the same thing from this angle. Correlation is always a mirror image. Now that you got a clue, what is the correlation between OTR and RM? OTR and RM.
0.36.
0.36.
So you should be able to identify correlation coefficient. That's the first one. Second, the second thing is to find, if I were to ask you which, identify 3 pairs of variables that are perfectly correlated. 3 pairs of variables that are perfectly correlated. Perfectly correlated means that they have a correlation coefficient of 1.
Of 1.
Yes. So give me 3 pairs. Watch the words. 3 pairs. The word is pairs.
quantity and quantity.
Yes. Price and price.
Price and price. The way you write it is this: price and price. And then we put the value there. Please don't use the and symbol. Use the actual A and B. So you have price and price, Q and Q, C and C, M and M, and all that.
C.
And please note this: perfectly correlated doesn't mean that it is highly correlated. It's perfect. Highly correlated can be 0.99. That's highly correlated, but perfectly correlated is 1. Note. All right, let's move on. Let's look at the next question. So which 2 pairs of variables are most strongly correlated with the response variable? Which 2 pairs? First, you need to know what a response variable is. Who can tell me what a response variable is? Which variable do you think is a response variable? The response variable, let me just mute to those of you who are making noises. The response variable is a Q. That's a dependent variable. That is a dependent variable. So which variables are strongly correlated with the dependent variable? You look for the ones with the highest value. And it says which 2 pairs. So you start with the highest. First one is P and Q. You have to mention it as a pair. So instead of saying P, you say P and Q. Negative 0.87. You show it. You show it clearly. P and Q.
0 TR and Q.
Negative 0.87. And the second one is
The OTR and Q.
Then, so that is negative 0.78. So know what we mean by variables correlated with the dependent or the response variable. Next one. Let's identify 3 pairs of variables that are highly multicollinear. 3 pairs of variables that are highly multicollinear. Remember that multicollinear has nothing to do with the dependent variable. This is a dependent variable. So when we're looking at multicollinear, we don't look there. It's rather for all the independent variables. Remember, multicollinearity Multicollinear variables are those variables that are highly correlated among themselves, independent variables. Independent though, independent variables. We've got nothing to do with a dependent variable. So you're looking here at the independent variables and you're looking for the ones that are the biggest. What's the first one? What's the number for the first one?
0.76.
All right. So you have 0.76. And then remember the variables, because that's the interesting thing. Variables. What's the second one?
0.74.
Correct. Third one.
0.73.
0.73.
If you don't take care, you will lose it because it can be plenty. Imagine the one you have.
0.71.
The one you have is even more than that. Okay. Remember, you mentioned them in order of highest to lower. Now, I could also have asked you which variables are least multicollinear. Least multicollinear here means that we're going to pick them from the lowest. So which is the first lowest multicollinear pair?
0.03.
That's wrong.
0.14.
That's wrong. You said 0.03. That's wrong. You should have said negative 0.03. That's what you should have said.
Okay, so does that mean that when it comes to the highest, we could ignore the
You don't
negative?
ignore the negatives at any point in time. But when it comes to highest, you still you think about it in terms of absolute value. But when you are writing it, you attach the negative.
I get you. I get you. Because there could be a positive 0.03 in there. I get you.
Exactly. What's the next one apart from negative 0.03?
0.14.
No, that's wrong.
Negative
Negative
0.29.
0.29.
0.05.
That is correct one, 0.05. Remember I told you that open your eyes. And it always happens that the best ones will always miss something. That's the second pair. And then you mentioned the variables. Third one. The third
0.14.
0.14. So you see the one who was mentioning 0.14 many times, now that it is a 10, she's not confused now.
Yes,
So
dog.
open your eyes. Sometimes the ones on the far edges are the ones that are the answers, but you missed them. You're looking inside instead of looking in. So how do you search for it? You got to search for it vertically, up to down, up to down, up to down. Now that is the least multicollinear. Let's go to the next one. Least correlated. So not least multicollinear, but least correlated. Least correlated means that it is either for the dependent or for the independent. So this one, you are not going to focus on only the independent, but you are focusing on both dependent and independent. Take note. So which is the first one? Least correlated. Least correlated. The first one is still this
Negative 0.03.
so this, and then finally you go down.
Yeah.
Master your game. Master your game. Next one. So that is how you do correlation. Understand the principles of correlation and then utilize them in the best possible. All right. Now that we've done correlation, the next thing and the final thing we want to do is to look at regression. Remember, practically, we said that correlation is looking at the association, but regression is looking at the causality. So we are going to the data set, and We're going to run in Excel the last one. Remember, next week, everything will be R. So you must download your R, or download the packages before you can. I'll talk about it very soon. So we're going to generate the regression result for this very Brukutu data set. How do you do that? Once again, you go to the data tab at the top. Follow me. On the far right, you choose data analysis. And instead of correlation, this time scroll down to regression. Double click it. It will open the regression parameter dialog box. Next, you have the input Y range. The Y range here means the dependent variable. So input Y range means go and collect the dependent variable. The dependent variable is a kill. So come to your data set, select the kill, drag it all the way to the end, and put that into the input Y range. In my case, you can see that it's from A1 to A41. When you make a mistake, do it again. Click on the input X range. This time, the input X range deals with all the independent variables. Here, they start from P all the way to Rn. Click P, drag it to Rn, and drag all of them down to the end. They will be collected into the input X range. Check labels. Choose output range. Click on the white space to the right of the output range. Select any empty cell where you want the results to be. Click on OK. A complete regression model is generated, as you can see on your screen. If you have been able to do this, you clap for yourself, because you are on your way to making yourself very proud. Very, very proud. This regression model, you will answer 10 questions on this. And we shall handle each one of these questions next time. More importantly, you have to learn how to generate these 3 things we have spoken about. You have to learn how to generate each one of them. Each one of them.
Hello, Doc.
Yes.
Please, could you take the latter part of the generation?
The latter part, you
Yes,
click on
after you
regression,
select, okay, sir.
select the input range, the Y range and the S range, take the labels. Click on the output range, select any empty cell to the right of the data set. And then once you've done that, you click OK.
Okay, I did that, but I'm getting, it cannot overlap.
Yeah, the reason is because you should go and check your input Y range and input X range. Check the values there. They should be A1 to A41, B1 to I41.
That's what I have there.
And then your output range, what do you have?
Output range, okay, so I clicked on J41.
Yeah. You click on J41.
Yes, please.
Well, if you click on J41, there should be no problem. Did you take labels?
Yes, please. Labels is ticked, output is ticked.
Yeah, but output range, do you have $J$41?
Okay, so now I'm using $J.
No, I'm asking whether you had that
$40.
first.
Yeah, that's what I had.
So read the thing inside there. The output range, let me see.
So I changed it now. So I'm using $J, $40.
Well, it doesn't matter. I don't think the problem is coming from there. Go to the input Y range. Tell me what's in the box there.
Okay, so I'm taking it again.
Go to the input Y range. Tell me exactly what you see there and read it to me.
$1 colon $41.
Why do you have $41? That's where the mistake is. It's supposed to be A1 to A41. It's just A. You don't have to go all the way to the I. Y range, right?
Yes, please.
Y range, you are only picking the things from Q. Only Q column.
Okay, please.
Only the Q column. From the top to the down. So that's why you made a mistake. All right.
Okay, certainly. Thank you.
So, guys, that's how you're supposed to run the regression. Okay, do that. Like I said, next week we are going to answer the questions related to regression. But I'm more interested in showing you what you should prepare before you come next time. Because what you prepare before you come next time is very important. In your slide, I have some commands here, which are in blue. After installing the R, which I put in the page, after installing the R and installing the R Studio, in the command window, okay, let me show you what I mean by command window. I'm opening my R. I'm opening my R to just show you something. Normally, when you open your R for the first time, you get something like this. You will get something like this, to be honest. Exactly how you see this. Please, do you see my R?
Yes, please.
Yes, please.
You'll get something like this with a cursor blinking on number 1. Where the cursor is blinking on number 1, that is what we mean the command window. That's why you type commands. Now remember, what I just opened is my R Studio, not the R. When you install both of them, the R Studio will hide on your computer. You'll not see the icon. But the R is what you see the icon on your desktop. But you don't have to click the R. Rather, go to your start button, search for R Studio, and then you rather click on the R Studio. You can even move it to the desktop or pin it to the taskbar. Once you open the R Studio, it will automatically run the R in the background. Once you have it like this, on the right here, you see a box, okay, a box. Just click on that sort of double window open box, maximize box, and then you'll have the 4 spaces, the 4 kind of interface. This is where you type your command. So you have to come to your notes like this and copy these blue commands. You can copy the words as well, but mostly the blue commands up to where the hash symbol is. So you copy it like that. You go to your R command and then you paste like I just did. You enter, cursor moves to number 2. You go to the next command, Jane, you copy, then you come here, you paste, you check the spellings are correct, you're done. Go to the 3rd command, you copy. Do that for everything that is here. Everything in blue, up to the hash symbol, everything. Next one. The next thing I want you to do is that anytime you see something like this, pay attention. Anytime you see something like require site, so anything that has require or library, okay, sometimes you not get require, or you may get something like library. Okay. Anytime you get something like that, pay attention to it. Because that is what you need for important things. Now, what that means is that it's a package. Anytime you have a require or library, it's a package. So before you run this command, And by the way, anytime you are running, you don't even have to run. We'll do the runnings here. So you go and check. This psych means that it's a package. So you come down to the bottom right here at the tab here, you see packages. So you see the package here. Okay. And then you click on the package, you click install, and then you go and type that psych. So you type PS, and as you type the internet, you see that the command itself will show. You should have an internet. You click on the name of the command and click install. This is a one-time thing. That's it. Once you install, you are sorted. You do that for anything that you see require a site before we go. Benjamin, that is how you do. When you finish and you want to save it in your My Documents, like you normally have done. That is how it works. You do this command before you come. We are going to run this quickly, and then we'll interpret the entire regression process. To whom much is given, much is expected. Qui multum datum.